Hello Year 10 Triple Science students. It is time for lesson 4 of the structure and bonding topic, where we are learning to understand the properties of materials and chemicals. Now, we've been learning about transition metals in the last couple of the lessons. And in today's lesson, we are going to be comparing transition metals to the group 1 elements that we had a bit of a look at in lesson 1 for revision of trilogy content. Now, instead of doing a driving question, we're going to be doing an explain task today. Now, you don't need to write this yet. This question will reappear later in the video. This is just to let you know the sort of task we're going to be doing. Now, in school, you would do a long piece of writing for this, and the teacher would mark it and give you a coloured dot. I'm going to do it in a different way today, right? You're going to mark this yourself towards the end of the video, and the video is here to take you through the theory of what you will need to put in your answer. So you will need to write an answer for this question. Summarize the similarities and differences in physical and chemical properties between the metals iron, cobalt, and nickel compared with lithium, sodium, and potassium. Now let's think about what do we already know about these metals. Well, let's think back to lesson 1, the sections of the periodic table. Group 1, they are reactive metals. Group 1 is the alkali metals. Transition metals, the central block of the periodic table. And we learnt about other metals, and then non-metals. We've got a couple of kind of semi-metals on the board here in germanium and antimony. And then we have noble gases, which are also non-metals. Now let's have a look for the elements that the question is asking us about. Iron, cobalt, and nickel, where are they? Down here in the transition metals section. So we're going to need to write about transition metals, physical and chemical properties. What about lithium, sodium, potassium? Well, they're over here, group 1. The alkali metals, group 1. So really what this question is asking is to compare the similarities and differences of physical and chemical properties of transition metals with group 1. Now let's revise what those properties are. The typical properties of transition metals. Well, if we're looking at physical properties, we've got these ones. Feel free to pause the video and just check in your mind. You don't have to write it down. What do these properties mean? Pause it now. Let's go through the answers. Obviously, this is a repeat from lesson 2 of this topic. High density, heavy for its size. Really, it means mass per volume, the number of grams per centimeter cubed, or sometimes the number of grams per litre. High melting point, only melts at high temperature. Shiny, wires can be made, can be shaped after heating. Good conductor. These are the physical properties of transition metals. High density, high melting point, shiny, ductile, and malleable, high conductivity. We looked at some unusual properties of transition metals. They form coloured salts. That's another property that they have. Those salts are quite often soluble, and they form a range of positive ions. So we've already looked at the fact that, for example, chromium can be 2+ or 3+. What else have we learnt? Transition metals make good catalysts. They are good at speeding up chemical reactions. That is a chemical property that they have. I think we had a quick look at this video in lesson 2, where manganese dioxide speeds up the decomposition of hydrogen peroxide. So manganese is a transition metal element. Here it's in a compound, manganese dioxide, but it still makes a good catalyst. They react with oxygen to form oxides, as we looked at last lesson in lesson 3. There's another chemical property. Transition metals react with oxygen to form oxides. They also react with halogens from group 7 to form salts called halides. So this was the subject of last lesson. So we can now start summarizing the physical and chemical properties just of transition metals before we compare it to group 1. So pause the video and see if you can list them all. You don't have to write it all down, just go through it in your mind. If there's somebody else in the room, say it out loud to them. See if you can check your memory of the physical and chemical properties. Pause it now. Okay, here we go with the answers. I've put high melting points, good conductor of electricity and heat, malleable, ductile, strong, shiny. And chemical properties. Transition metals react with oxygen to form oxides, with halogens to form halides. They make good catalysts, and they form a range of coloured salts containing a range of positive ions. Right, let's start comparing these to the other metals, lithium, sodium, and potassium from group 1. So here comes some revision of the properties of group 1 elements. Right, firstly, group 1, they are softer and easier to cut compared to other metals. Transition metals are hard and alkali metals are soft. Now, transition metals we said are shiny. Alkali metals are also shiny when they've been cut. They tarnish very quickly in air because they react with oxygen to form this kind of grey crust. But when you cut them open, they are shiny. So they share that property with transition metals. You will also have learnt in the past that they react with water to form alkali, hydroxide, and also hydrogen gas. Transition metals do not do that. Okay, so alkali metals are softer than transition metals, and they react with water, but they are shiny when cut, so they share that property with transition metals. Right, now then, moving this along, what other properties? Oh yeah, the reaction with water is a chemical property, whereas being softer and easier to cut is a physical property. What other properties are there of group 1? They are less dense than other metals, so less dense than transition metals. They have lower melting points than other metals, so their physical properties are a bit different to transition metals. We didn't need to worry too much about the trend standard group for this topic, but you do need to know it for your trilogy. Right, what else? Now then, transition metals will react with halogens to form halides, and alkali metals do the same thing. Here is sodium metal being placed into a container of chlorine gas. So alkali metals will react with group 7 to form halide salts. In this case, sodium will react with chlorine to form sodium chloride. Now what they do is they add a little bit of water just to initiate the reaction. The alkali metal starts reacting with the drop of water, produces some heat, and that heat then ignites the reaction between sodium and chlorine. And when that reaction happens, there we go. Now have a look at all this white powder. That is sodium chloride being made. So sodium reacts with chlorine to form sodium chloride. Group 1 will react with group 7 to make halide salts. We said transition metals will react with oxygen to form oxides. Alkali metals will do the same thing. So here is an alkali metal, they're normally stored under oil. Doesn't look very oily, that oil, but yeah, it is oil. And here is a jar full of oxygen gas. So when the alkali metal is placed into the oxygen gas, again, they will add a little bit of water just to initiate the reaction. And then you'll see boom, there it goes. The sodium and the oxygen reacting together, and then check out all this white powder being made afterwards. That is sodium oxide. So alkali metals will react with oxygen to form oxides. For example, sodium and oxygen makes sodium oxide. Right. Now here we go. Pause the video. What are the physical properties of group 1? Let's check the answer. The correct answer was D. They are softer and have lower melting points than other metals. What about the chemical properties of group 1? Pause the video. Is it A, B, C, or D? Here comes the answer. It was B. They react with oxygen to form oxides, halogens to form halides, and they react with water to form alkali, hydroxides, and hydrogen gas. Can we summarize that all together? You don't have to write all this down yet because you're going to be writing in a minute. So think to yourself, try and list them. Can you remember them all? What are the physical and chemical properties of group 1? Pause the video and try to summarize it. Okay, here we go. Softer than other metals, lower melting points than other metals, lower density. That's why they float on water when they're fizzing with water. They've got lower density than other metals, but they can be shiny when cut. They tarnish in air because they react with oxygen, and in fact they react with oxygen to form oxides, react with chlorine and other halogens to form chlorides and halides, but they also react with water to form alkali and hydrogen gas. Right, let's put it all on one page. Here we go. Right, now you can come back to this if you start to get stuck in your writing. Remember, you're going to be writing about iron, cobalt, and nickel. They are transition metals. They have these properties. You're going to be writing about sodium, lithium, and potassium. They are from group 1. They have these properties. You're going to need to compare these 3 metals to these 3 metals by comparing their properties. Which ones are the same? Which ones are different? So if you get stuck, come back to this one. Just remember, I've put in here that they form a range of positive ions. Please remember that group 1 only form 1 plus ions. They have one electron in their outer shell. They lose that electron to form a 1 plus ion, whereas transition metals can lose a varied number of electrons from their outer shell, so they form a varied range of positive ions. Right, here we go with the question. So you're going to pause the video, copy this title. You don't have to copy the whole question. The question is kind of contained in the title. Explain how transition metals compare to group 1 metals. But make sure in your answer you refer to iron, cobalt, and nickel. Refer to lithium, sodium, and potassium, because that is a specific example in this question. So pause the video, write your answer. You can write in bullet points, or you can write in sentences and paragraphs. That's up to you. But write a complete answer, and then we're going to mark it. So pause the video for as long as you need. We're not going to go step by step, orange, green, yellow, blue. Just do one answer for this. Okay, right. Now let's talk about marking this. Normally, in school, your teacher would give you a coloured dot. You're going to have to do that for yourself. You just write down what sentence you think you've achieved. So in my explain task, I was able to. Now, you won't know what you've achieved until we look at the answer. And I've broken the answer down into colours to try and give you some clues. But you're going to need to, in a minute, think about, were you able to include facts and keywords? Were you able to go further than that and show correct understanding? Could you go further than that and actually explain this unfamiliar situation using detailed understanding? Did you actually answer the question, the scenario that's contained in the question? And then were you able to combine a range of detailed understanding to explain that new situation? Okay, so let's see what I put here. All right, okay, let's go through this one bit at a time. You can pause this and you can read through it. If your answer is mostly like this, then you've achieved green, correct understanding. If you haven't achieved that, then you've achieved orange, describing some facts and keywords. If you've containing these middle points here in your answer, then your answer is most likely yellow, using understanding to explain. And if you've managed to combine in some of these extra ideas, like about ions, and some just extra bits about their properties, that would be a fully extended answer for blue, combining in a range of understanding. If you have actually managed to compare physical and chemical properties of lithium, sodium, potassium, and it's generally correct, then you can give yourself yellow, right? If you haven't quite done that, if you've mentioned some properties, but you haven't made it clear which properties belong to which metals, that'll probably be more green. So pause it, have a read through, and think about how your answer compares to this. Okay, so now can you please decide what your achievement was? Write a sentence. And we've got an opportunity now to do a try now question. Oh, here we go. Right, try now questions. Now, if you gave yourself orange, now do this. If you gave yourself green, now do one of these, or both, depending on what's appropriate. If you gave yourself yellow, now try and do this. If you gave yourself blue, there is an extension question. The extension question, you need to try and do it without the teacher explanation. That's why it's extension. But the answer is coming up. Okay, right. Now then, let's have a look. If you're doing the extension question, why do alkali metals have lower melting points than other metals? Well, they have lower melting points because the metallic bonding is weaker. I'm just going to go through what metallic bonding means. Metallic bonding is the attraction between positive ions and delocalized electrons. So all metals share this structure, positive ions surrounded by delocalized electrons. And the attraction between the positive ions and negative electrons is called metallic bonding. In alkali metals, the attraction between the ions and the electrons is weaker. That means it takes less energy to break the metallic bonding, so it will melt at a lower temperature. Right, if you are looking for the answers to the other try now questions, come back to this. Okay, all the answers are in here somewhere, so look for the answer that you are working on and see if you got it right. And finally, flicking about in a PowerPoint. Right, well done for having a really good go at that. A little bit different to normal, marking it yourself. I hope that worked okay for you. I hope you were able to use the teacher answer to tell if you are getting this right or wrong. Well done for your effort and your work on this. Please remember to go back to Show My Homework and complete the 10-question quiz about transition metals and alkali metals. And well done for your work. Keep up the effort. Good job. Keep it going.